All right. All right. So in previous tutorial, we stopped at tutorial. We already complete. Finished the tutorial 3, but we left out tutorial 2 at question 7. So we shall continue from tutorial 2. We complete tutorial 2 first, and then we follow. We continue tutorial 4 and 5. Okay. So question 7. Um, I think some of you already answered these questions. An A4 size binary image is scanned at 200 dpi resolution. Calculate the memory storage required to store this image in an uncompressed form. Okay, so basically, of course, if the questions asking about the A4 size, the size will be given. Don't worry about that. I don't need you to memorize the A4 size. So this would be the standard size in inch for A4. But of course, if you want to convert to cm and mm, then you can convert it using the suitable conversion value. So the total number of dots per pixel will be 8.27, which is this one, multiplied by this one and multiplied by 200. So you will get something like this one, and you round off to the integer. That's all. Okay. So basically, usually we will actually it depends on what cases. For example, in when you are doing calculation in terms of intensity, pixel base, usually we will round off it to integer. And of course, that is depends because the integer, if the intensity, for example, is spanned from 0 to 255, so of course you need to round off to integer. But if it is a normalized value, so it's no point for you to round off, because rounding off would cause it to become one or either one or zero. Okay, because after normalization, the value always between 0 and 1. Okay, so you have to look into which condition is it. Do not perform round off as you like lah. Okay, so storing a binary image in an uncompressed form needs 1 bit per pixel. So we get a total of 19336 bits or 18.8828 lah, divided by 1024 only. So convert to byte. So this we divide by 8, and then we divide by 1024 to get this one. Okay, so I think this one is called, quite the calculation here should be in chapter 1 or chapter 2 lah. Okay, I think chapter 1 mostly. Okay, calculate the printing resolution if an image with pixel dimension of 1002 by 1006 is to be printed at a size of 8 multiplied by 10.6 inches of a paper. So the width is 1002 divided by 8 will be this one, and the height is 1006 divided by 10.6. Actually, it's just divide the width with the printed size of width, and then divide this the height with the height of the printed size. That's all. So you will get roughly lah. Most probably you won't get something similar. Identical lah. Exactly 150 lah for both the width and height. But usually you will get something very close. If let's say you get something very, the discrepancy is very high. You have to recheck your answer. Okay. Usually it's just within one or two. Okay. If let's say you get 155 or 160, usually most probably is wrong. So question 9, determine the print dimensions in cm if 1005 times 1002 image is to be printed on the paper at printing resolution of 330 dpi. So dpi is for dot per pixel. So whenever you see dpi, for sure is referring to printing. Okay, dpi will be in terms of screen resolution. So 1 centimeter is equivalent to again, for my subject, I would encourage you all to use at least 4 decimal places to perform the calculations. Okay, I'm not sure about other lecturer, but I would prefer four decimal places because no matter in in electric circuit theory, I mean all the calculation with regards to electric circuit, the ohms, etc. If you use 2 or 3 decimal, 3 would be okay. But if you use 2 or 1, usually the discrepancy of the answer is quite large. So sometimes it's very contradictory for me to allocate you the marks or not, because when especially in terms of electric base, when the value is discrepancy of maybe 2 to 3, so it's quite difficult, 11 ohms and 2 ohms is a big difference. So that is because sometimes it's because of the calculations. So best to use 4 decimal place. So this one basically you just divide lah, okay? So this one would be this inch, and this one, oh sorry, this inch will be this cm, and this one will be this cm, okay? I think that's all for, yeah. 7, okay. Again? The resolution for the height and the width. Okay, height and the width. You mean question 7, right? Okay. Okay. For these questions, I've been thinking of this question as well, because previously, I think I thought to be 8.27 multiplied by 200 and then plus 11.67 multiplied by 200. But if let's say like that, then how many dots in 1 inch? Can you see how it comes from? If you have 200 dots in 1 inch, which means 1 inch times 1 inch, a square box, you have 200 dots. So if let's say you take this one multiplied by 200, you take this one multiplied by 200, and then you plus, you will get 400, right? So which means in 1 inch no longer 200 dots. So that is the logic here. So we have which means you get the width and height and then multiply by 200. So you will get the total 200 dBi. If let's say you get width multiplied by 200 and then height multiplied by 200, you will get actually a double up, double the dBi, something like that. Okay. So any questions from those online? Okay. So if none, I will upload this question. I'll upload these solutions to the Google Classroom later on. So let's move to tutorial 4. Okay. We yet to start, right? Tutorial 4. Okay. So this is tutorial 4, and I think I already uploaded tutorial 4 and tutorial 5 in the Google Classroom. So let's look into this one. Color scheme on image and video, image manipulation, image equalization, and spatial filtering edge detector. Okay. So using Hsv color model, color are represented by hue, saturations, and brightness, V. Sometimes we call it as intensity, Hsi. Of course, there will be a bit different, but basically the brightness V and the intensity I would be more or less the same. Okay. The hue value normalized between 0 to and 1 for the primary and secondary color are described in table 1. Always remember the primary color is RGB, the secondary color is CMY, no K. K is black color, but K is actually not in the secondary color model. Okay, it is added in later on by the manufacturer, but it is too common to be used, so we add in K over there. Okay, so please do not lose this kind of marks. Primary and secondary is very direct, and if you usually the marks given would be very less, maybe 1 or 2 marks. So if you get wrong, so basically no marks given. Okay. So based on the table, describe the color represented by the following combination of hue, saturation, and brightness value. I hope when it comes to HSV, you have the idea what is HSV like, looks like. It would be something like a cone shape or a rectangle shape, but in so it would be something like this one, okay. And the degree here would be the h. The height would be the either v or I, and this one, I mean, how far is from the origin would be the saturations. Okay. So based on the table, describe the color represented by the following combination of hue, saturation, and brightness. So you have your color at this column, column at the right hand side. For hue, you have this different value. Of course, this is only hue value given. Why is not given the S and V is that S is referring to saturation, V is referring to brightness. Okay, so the first question, A, B, and C. Let me pick someone to answer from online. Then, okay, you just give me the color lah. A is what color, B what color, C what color. Let me check. 学文 You may put it in the chat box, or if you want to share screen, it's fine. Are you there, Sherwin? All right. Oh, yeah. Then put your answer in the chat box lah. Magenta. B and C. Red and blue. Red and blue. Okay. Thank you for the answer. Okay, so the answer is correct, but nonetheless, you have to aware of the questions. Usually, I seldom give free marks. I seldom give free marks. So the answer for magenta is all right if, and I mean the answer given by Sherwin is all right if and only if S and V are both one. Okay, so always check the S and V different value. So H is referring to what color is it? I hope you all still can recall. The H is in 360 degree. So this 360 degree would referring to different color. For example, maybe at this side would be red color, blue color, orange, and so on and so forth. Okay, so it is in 360 degree, but the saturations and the intensity would be affected by the, the saturation and intensity will affect the color as well. Okay, please do not ignore this one because if you have a very blue and dark blue is different, red and pink is different. Okay, so for first one, because you have S is equal to 1 and V is equal to 1, which means it is fully saturated with this color, and the intensity is quite bright because 1 is referring to bright and 0 is referring to dark. So this one is just simply, refer to this table, so you will get magenta. But magenta alone is not sufficient. You have to look into S and V. So magenta, because the hue value corresponding to magenta and is purely saturated and fully bright. Okay. So for the second one, B, yes, the value is 0 degree, which means it is this one, 0 lah. So it is referring to red color, but the S, the saturation is 0 to 0.25 only. Okay, 0.25, which means it is not so saturated. Okay, when it is not so saturated, so which means it won't be red color. It will be something being dilute. Okay, and the V is 1, which means it's quite bright color. So the color would be pink color because hue value correspond to red and is slowly saturated to fully bright. Fully bright. Okay, so whatever pink also can, light pink, dark pink also ever pink also can. Okay, so the why this is pink is that it is affected by the saturation over here. Okay, so for the third one, blue is correct because the hue value is corresponding to blue, but you have your velocity, sorry, not velocity, V is the brightness of 0.25. So 0.25 is more biased towards 0, which means very dark. So you should have a dark blue, okay? Because the hue value correspond to blue and it's purely saturated and low brightness. That's all, okay? So for the second questions, I think it's a bit difficult. Someone would like to share the screen for the answer. If not, yeah, I don't think this one can be put in the chat box. Anyone to share your screen? Okay, Nana. It's okay. Then for this question, I can present it. Question 2. I think question 2 and question 3 is correlated. No. Okay. So question 2 is I would say question 2 is an application-based question. Okay. Because in the sometimes in tutorial we learn something more towards applications. I mean working and so on and so forth. Because in the lecture notes, I did not include this one. Okay. So please focus. Produce a histogram for the following image F, which has a grayscale value encoded in 3 bit ranging from 0 to 7. Okay, 0 to 7. But I think this one I did make a mistake. Should be 0 to 6. Okay, should be 0 to 6. Because the max value here is 6 only. Okay. Okay, so this is the, let me check the question. Okay, this is the question. Okay, so A, produce a histogram for the following image. So first of all, you need to produce a histogram. Histogram is a bar histogram, and F with a grayscale encoded in 3-bit 0 to 7. Okay, so first of all, in A, we need to plot the histogram. To plot the histogram is very easy. First of all, you need to calculate how many 0, how many 1, how many 2, 3, 4, 5 until 6. Because the max available here is 6 only. Okay, so calculate the frequency for I mean amplitude or frequency also can, which means number for 0 you have 2, 1, 2, and for, let me use the snapping tools. So 0 you only have 2, 1, 2, and then followed by what else? 1, 1, 2, 3, 4, 5, 6, 7. So you have 7, and then followed by number 2, 1, 2, 3, 4, 4. What? Okay, here. Okay, and then so on and so forth for number 3, 4, 5, and 6. Okay, so after that you plot this one. Of course, if you want to plot until 255 also can lah. Up to you lah. But nonetheless, you have to show this part lah. Okay, and you and whenever you all draw the histogram or chart or graph. Make sure you give me the legend and the axis accordingly. Okay. For example, you don't just put 0 to 6 and 0 to 8, and you did not put pixel distribution or grayscale level, and also caption is still okay. Caption is still okay, but the exits, naming of the exits must present over there. If not, I will not give you mark. Okay. Just like the SI unit. If without SI unit, basically will be the marks will be deducted. Okay. So this is for A. That's all. Okay, for B, plot the normalized histogram to show its probability distribution. Okay, so this we need to, I would prefer to tabulate a table for this one. So for C, perform equalization on the image in 2A, this one, and plot the histogram for the equalized image. So which means after you, for B, you need to perform the probability distribution, and for C, you need to perform equalization. After that, you replot the histogram. Okay. So for B, I think this one already given in the lecture notes. These two equation is in the lecture notes. So equalized pixel level, you have these equations, and probability distribution will be this one. Basically, probability will be, how often, for example, you have two colors, apple and orange in a box. So let's say you have 5 of apple, 5 orange. How many probability you will get an orange? Something like that. It's very simple. So basically, you just take the if you want to calculate the probability of orange, you just take the total number of orange divide by total number of everything inside the box. That's all. Okay. So the logic is the same lah. Number of pixel and the total number of pixel. Okay. So number of pixel will be the specific number of pixel in that intensity level. Okay. So based on this histogram, you have 0 to 6, right? So the pixel level will be 0 to 6. Okay. You don't after 6 you don't have any pixel value. So calculate the pixel value here according to this one. So you have 2, 7, 6, 4, 1, 1, 1. So 2, 7, I missed out 1, 5, 1, 5. Okay. So the plot everything here. So the total will be 20 lah. Why 20? Because you have 5 times 4 times 5. So in total you have 20 pixel. So this one. So calculate the probability. Basically, is 2 divided by probability distribution will be based on this one. So you have 2 here divided by total number of pixels, which is 20. So 2 divided by 20, you get 0.1, so on and so forth. So after that, you sum up everything from here, you will able to get 1. Why? That is because 20 divided by 20 will be 1, right? Okay. So the probability, the summation of the probability always is equal to 1. Okay. So this is 1. So this is sort of cumulative, I would say, cumulative calculation, because the question, this is to get how many, the total number of pixels, which is smaller than the current pixel level. So current pixel level is 0. So how many is smaller or equal to, okay, don't forget the equal. So you have 2 lah. And then later on, how many pixels smaller or equal to 1? So which means 7 plus 9, you get, 7 plus 2, you get 9. So how many pixel value is less or equal to 2? So 7 plus 2 plus 5, you get 14. So basically, just cumulative, you get 17, 18, 19, and 20 lah. Okay, but this one don't have total lah. Okay, not applicable. So equalize is just what divided by what 2 divided by 20, right? Equal. Oh, sorry. You use these equations. Total number of pixel. So this value divided by total number of pixel, which is 20, multiplied by the max value. So the max value here is 6, because the highest number is 6 lah. Okay. So you just multiply by 6. 2 divided by 20 will be 0.1, multiplied by 6, you will get 0.6. Okay. But if let's say the question say, now I want to normalize the value to 100. So which means you have your intensity 0 to 255. So if let's say you want to make it to 100, you normalize the range is 100. So which means from here, you need to get the number of pixels divided by total number of pixels and multiply by 100. Because this is the max scale intensity, the scale that you want to, push the range. Okay, if you want to push it to the full range, which is 255, so put it as 255. Okay, but for the current, we put it as 6 lah. Okay, so again, this continue, 9 divided by 20, multiplied by 6, you will get 2.7, so on and so forth. Okay, so at the end, you will find that the value is 6 lah, because the maximum range will be 6 only. For this case, if let's say you have 20 divided by 20, total number of pixels lah, because this is cumulative, right? So the last value must be equivalent to the total number of pixels. So the total number of pixels for this case is 20. 20 divided by 20 will be 20 lah. If let's say the maximum scale value here is 100, so 20 divided by 20 multiplied by 100, so you will get 100 over here. Okay. If you are not getting the maximum scale over here, something wrong. Okay. So the logic is there. So if there are changes, I believe you all know lah. Okay. But this, I mean, to tabulate the table, perhaps you need some practice lah. Okay. So since we have, this is not normalized value, this is a normal integer. So because you have values more than one, right? So obviously it is not a normalized integer. No, sorry, not a normalized value. So you have to round off it. If this is a normalized value, then you no need to round off lah. Okay. And usually if it is not a normalized value, I would prefer you all give me the answer in 4 decimal place as well. 0. For 4 decimal place. Okay. So this is 0.6. So you round off to become 1 and so on and so forth. So the max would be 5.7 will become 6 lah. So you have 1, 3, 4, 5, 6, 5, 5, 6, 6. So based on this one, you can use this answer to redraw the histogram and answer the question C. Perform equalization. Okay. So from here, you will need to plot this graph and you get this one. Okay. Basically, this is not so necessary because it's not requested by the question also. Okay. That's all until here. Normalized histogram. You need to plot normalized histogram. So the normalized histogram would be this one, 0, and the value here should be follow this one. Okay, because this is the probability distribution. I mean, you check, is it correct? 0. Yes, correct. Yeah, correct. You use this value. This is the value after you normalize. Okay, so that's all for B. And for C, we perform the mapping. So basically, you have this, which is from the original questions. So you just map that. For example, look at this table. 0 map to 1, 1 map to 3, 2 map to 4, 5 map to 6, and etc. So from here, you will become, this is the mapping, 0 map to 1. So for every 0, it will become 1. 1, this is 0, become 1 as well. And then 1 is become 3. So this is become 3, 3, 3, 3, 3, 3, 3, and so on and so forth. Okay, so this is the equalized. And from this equalized equations, you can plot this one. Okay, you can plot this chart. Okay, anyone don't understand or any questions? Any questions? No, okay. Usually this kind of question worth a lot of marks. Okay, because it involves many steps. And yeah, but anyhow, in practical, I mean, in terms of practical, I seldom use histogram equalizations to solve image processing issue. That is because sometimes I'm not really, it would be visually, if you want to, I mean, process the image to make it visually pleasant, I think equalization is okay, can be used. But if, let's say it's meant to be, you need to apply subsequent, processing towards the input image. I'm not so prefer histogram equalization because it may disturb the entire distribution of the histogram throughout the image from the step after you've done the histogram equalization. Sometimes I would think that it's introduced noise to the input image. So, but of course that is based on different applications. But if you want to, just simply enhance the image to make the image more pleasant to be see, to be viewed, I think should be all right. But in terms of image processing, which involve many subsequent steps, I sometimes I'm not so prefer this one. I think there would be many more pre-processing method. For example, the standard deviation method, transferring to what we call that one, SVD we call standard. I forgot what is the full name, but it's transferred to another dimension. That one would be much more better lah. Okay, but of course the mathematical calculation is much more complex lah. Okay. Okay, question 3. Let us see the original. The histogram of a particular grayscale image is shown in figure 1. Based on the histogram, determine if the image is dark or bright. What operation can be used to enhance the image? Okay, this is very simple. let me pick someone else. Yen Chang So. Yeah, you may share your answer in the chat box. Okay, how about B? What operation can be used to enhance the image? Okay, this is very simple, I would say, like the dollar explorer. Ask you where is the bag, something like that. Okay, so based on the histogram, determine. I've been highlight this one quite many times. So, you know, when you move the histogram towards the left side, what image you would expect. When you move the entire histogram towards the right side, what would be the effect and this and that lah. Okay, so I think even though actually you can correlate, but if you want to memorize it also can, because if you understand the distribution of the grayscale from 0 to 255 is not difficult at all. Okay, so this is a dark image. Why it is a dark image? That is because the all the histogram is more focused towards the left hand side, which is quite dark lah. Okay. So what operation can be used? Histogram stretching, histogram equalization can be used to enhance actually many more. Okay, but the most common one that we have learned would be histogram equalization. Histogram equalization and histogram stretching is the same. Just that another thing is histogram specification. That one is to equalization is to spread out the histogram. Specification usually used to map to a specific patterns. For example, I just want the histogram to be distributed throughout this area. So I can use histogram specifications. Okay. It is actually some modification of the histogram, modification from the histogram equalization. Okay, number 4. Briefly explain the principle of spatial filtering in image processing. Define function of mask in the filtering process. So whenever you see the word spatial, it is dealing with spaces. Okay. And in terms of image processing, for sure it is about the connectivity, the relationship between this and the adjacent pixel and so on and so forth. Okay. So define the function of mask in the filtering process. Anyone? I picked someone from the physical class. Yeah, you in the classroom meet, right? Yeah, you can share the screen. Oh, share the screen. One moment, let me. Spatial filtering is used to blur or sharpen an image, introduce distortion, and produce a variety of spatial effects. A mask is a filter. Concept of masking is also known as spatial filtering. Converting a mask and assisting and moving the filter. Okay. But for the first one, spatial filtering is correct, but sometimes I would give my answer in a more flexible way. Is that I would say it can be used, for example, in what because spatial filtering has so many. Even I cannot. Some I even don't know. So because based on the first sentence, spatial filter is used to blur or sharpen an image, which means the function will be limited to blur or sharpen the image. Okay, to some extent, it's not so safe. Okay, so if you say that, for example, spatial filtering is used, for example, to blur or sharpen an image would be safer. Okay, depends on the moderator or the examiner. If he is very strict, so perhaps the first statement is incorrect. Because you limit the function of spatial filtering, which is incorrect. Okay, but definitely blur and sharpen the image is part of the cliche example for spatial filtering. Okay, okay, thank you for your answer. Overall, is correct. So spatial filtering perform operation on neighborhood of every pixel in an image. So basically, spatial filtering is sort of local operation, okay, whereby it's considered not only the current pixel but the neighborhood pixel as well. So the neighborhood pixel is part of the important keywords. Okay, the neighbor pixel, or you can use some other words to describe that. But nonetheless, you have to highlight that it is not only considered the current or the center pixel, but also the neighborhood or any adjacent pixel. Okay. Example of spatial filtering include image smoothing and sharpening. Okay, so image smoothing would be blurring, okay, and sharpening would be sharp image. So this would be the general equations for spatial filtering, whereby fxy is your input image, not input image, but input specific. Yeah, you can see this as an input image, just that you have your input pixel x and y exit, and t is the spatial operations or the local operation, depends on what it is, and gx will be output image. So where fsy is an input image, gxy is the output image, and t is as an operator of f defined over a neighborhood of point x and y. So the operator can be applied to the pixel of a single image. Our principal focus in this chapter, so or to the pixel of a set of image, such as performing the element-wise sum of sequence of an image for noise reduction. Okay, so you have different applications. Okay, find the value of the pixel of figure 2 below after it is filtered by 3x3 Gaussian filter. Let me see. Okay. So this is the Gaussian filter 3x3. So this would be the an example like 3x3 input pixel. So after apply this one, then what is your answer? This is very direct, which means you just apply this one. Which means you just apply this one to this block. Okay, because this is 3x3, this is the origin. So for the rest, you need to do padding. Okay. So I will just give the answer. But of course, if none mentioned in the, if nothing mentioned in the, if nothing mentioned in the questions, you can do whatever padding you want. Okay, you can do whatever padding. But most of the case by default would be a zero padding. Okay, but if you want to use reflections, also can, but you make yourself difficult. I would say. Okay, so basically you just put this filter to the first, place the center to the first, and then so on and so forth. So you would have something like this one. So I just give two examples here, 1 and 1 1, which means the first one, and 2 2, which means this one. Okay. So basically you have 0 because for 1 1 you have 0. You know these 9 blocks is involved. So 0 multiplied by 1, and then plus 0 multiplied by 2, and plus 0 multiplied by 1, 0 multiplied by 2, and 220. This one 220 multiplied by 4, and 238 multiplied by 2, this one, and continue to this one, this one, this one. Okay, so later on divide by 16. Okay, you will get this value and round off to become this value. basically you just put a mask at a specific area lah. But what you need to do first is to perform the zero padding lah. That's all. Okay. So after that, you perform all calculation for all these 9 blocks. You will get this value. Any questions regarding this one? Because this is just repetitive. As long as you know the pattern, the rest is just about calculations. Okay. So question 6 is about Sobel, right? Okay, question 6 is about Sobel. Use the Sobel operator given below. Compute the gradient vector magnitude, and direction of gradient vector. This is not really included in the lecture notes as well. Always remember to calculate the magnitude, we need to use the formula. The formula which is this one. Okay, this is a very common formula. I think we learned this since Form 5 maybe. Okay. This formula is quite useful. Just my opinion. If you later on, of course, if you are not doing research, so you may not really using all this sort of common mathematical equation. But if let's say you are doing a research and you are doing part of modeling, which means you need to combine several features to become one mathematical equations. Some of these are common equations like the harmonic mean, like the magnitude is very useful. And the novelty is very high. Okay, because quite rare people will get this kind of model. But if, of course, you are working as an engineer, you still need to know the basic Pythagoras theorem, all those. Because I've been quite curious because last time I have been encountered something, the die is not in the correct position. So we need to, do some calculation to get this one and this one. Many people cannot do this. I'm not really sure why. To calculate the values here, which means you have a slanted rectangle. Okay, you need to calculate this value and this value. Because this is a right angle triangle, so for sure this is 90 degree. So I found that many people cannot do this kind of calculations. So it's quite weird. This is, at least you go and Google. I'm not really sure why. But yeah, these common calculations, I hope you all at least know. You don't need to memorize it, but at least when you encounter such an issue, you know how to Google. I know Google is very powerful, but many people don't even know how to Google. So if you know how to Google, I would say you have a tool which can save you for the whole life. Okay, as long as you can type in how to calculate the Pythagoras theorem. If not, I'm not really sure. Okay, so this would be some basic mathematics which is very important for your engineer life, especially dealing with image and also the E&E. Okay. So for this one, so first of all, for the first question A, you need to calculate the gradient vector, Gx and P. Remember, the given value is Gy, Gx. Why it is given Gy and Gx? I hope you all can recall that the Sobel is not it's not only one direction. It has 2 directions, and then later on combine the direction. So you have x horizontal direction, which is x, vertical direction, which is y, and then you have, this is your input image, image P. Okay. Pixel 2121. I think it's this one. Okay, so you perform the calculations. First of all, start with Gx and then followed by Gy. P multiplied by Gx. Basically, you just multiply as it is. -1. This is Gx. -1 multiplied by 38. And then just multiply as it is. The triangle. Put this on this and multiply and plus together. So you have negative 1 multiplied by 38, negative 2 multiplied by 66, and so on and so forth until the last one. And then add in to become 1, the one value. Okay. Gy also the same. Multiply gy. One moment. Gy. Okay. So basically, you just multiply and you will get this value and this value. It's normal to get a negative value because you have plus and minus here. And then later on, you need to count that. That's all for the gradient vector, because the gradient vector is possible to have negative value as well. So later on, after this one, you can actually get the magnitude. Okay. Basically, this is the equation to get the magnitude. So this is the magnitude. Okay. Any questions? You mean zero padding, right? Yeah. Actually, I'm aware of it. Actually, I'm aware of it. Supposingly, this is the center pixel. Do you understand? So I think I answer your questions. I think this is the center pixel because 2, 1. If it is 2, 2, so my current equation is correct. Okay. If this is 2, 1, supposedly you need to do zero padding. Okay. Yeah, thank you for the reminder. And yes, there is arrow here. So 2, 1, if this is 2, 1, so make sure you put zero padding. And then you just multiply as it is. Okay. But I'm very lazy. So I will change it to 2, 2. But nonetheless, your answer is correct. Okay. Don't worry about that. Okay. So I will remove everything. I change it to 2, 2. Okay. So the gradient is the same. I mean, not the gradient. The magnitude is the same. So always remember, this is how you get the magnitude. No matter in what cases, to get the magnitude, you are using the same old method. Okay. If you have two different points, x1 and x1 and x2, for example, x1, y1, x2, y2, So basically, this is the value and this is the value. You need to characterize x at one place, minus by x2, and plus y1 minus by y2, square root it, and square root it. Okay, this is how we get the magnitude. Actually, this one is exactly from this one. Okay, I think initially in Form 4 or Form 5, we learned this one first. And then later on, we incorporate in later stage. Okay, so basically you get 25 or 151, but of course you have a negative sign here. But nonetheless, the square here is actually to modulus it or to remove the plus and negative, because in magnitude we don't have any plus and negative sign. Okay, so later on you will get something like this one. But of course, if you are using the zero padding, you are using zero padding as this one. So if you put zero padding here, so of course the answer will be different. But I believe you all know the idea, right? Okay, that the answer will be different. But later on I will amend first. But of course I'll amend this one. Okay, but nonetheless, I don't think your answer is wrong. As long as you check the, how it is being multiplied, so it's okay. Okay. So the direction of the gradient, this is not in the lecture notes, I think. Okay, the gradient angle at the pixel 2, 2, you see, should be 2, 2, right? It's tangent, arctangent y divided by x. Okay, so arctangent y divided by x, what is the y value? Is this one. Okay, you just put your y value there, and the x value, which is this one. So, and you just press your calculator. Okay, but always make sure you include the sign, positive or negative, because we are dealing with the angles and etc. The sign is very important. If you put in the wrong sign, you may calculate from different angles. Okay, so for this case, we take this as an example, 2, 2. So you will get this one, and this is actually equivalent to this one. Okay, so since it has a negative sign, then the angle shall be 180 degree minus by 9.4. Okay. Before you go into the examination hall, make sure you know how to calculate from radians to angles. Okay. You are not able to access the Google. So and because radian to degree is convertible in your scientific calculator. So you have to know how to do it. And I will not give any, of course, there is sort of conversion value over there, but I wouldn't give that one, okay? Because this can be pressed from the calculator, okay? So make sure you know how to convert from degree to radian, radian to degree, okay? So always remember, so you have a negative sign. So since you have a negative sign, so the angle should be from the other way around. So 180 degree minus by 9.4, you get this one. So this is the degree of the gradient. Okay. So in Sobel, why we need to know the magnitude is that we want to know the strength of the operator. And why we need to know the gradient, I mean the direction of gradient, because we want to know the direction of the edge. Okay. So we are going to search the edge at a specific direction. So this is what Sobel, I think Kenny as well doing this one. I'm not sure about Robert, Pruitt, yes, doing this one as well. Okay, because they are search the edge based on the direction as well, direction and magnitude. So we are actually doing this. But of course, nonetheless, for Sobel operator, actually the calculation here is just very, very small part, because you can see we only calculate, 3 times 3 pixel block. But in actual world, I mean in actual application, your image is like 1,000 times 1,000 or maybe 100 times 100. So if in case you are going to do the software operator, you have to know that actually you are performing this one. You can see this as one local operator. So you have actually up to 1,000 operator. This is just one block in a very small image. So basically, the software operator will be doing this block by block, so on and so forth until you finish the entire image. So from that point onwards, you will know that the magnitude and the direction is very important to trace the edge. Okay, so this is the idea, but we are not able to do the, everything in one question examinations. Okay. Let me see if question 7 is long. Okay, we will continue. Let me finish this one first. This is the degree, 170 degree. So arrow shows the direction of the gradient vector. In order to detect the edge pixel, the gradient magnitude for all pixel is computed. Pixel with gradient magnitude larger than a preset threshold is labeled as an edge pixel. So which means this one is actually sort of threshold value over there. So not really a threshold value, but a magnitude. But there is a default preset value. For example, magnitude which is greater than 100 is edge. So, this is 153, so it is an edge, something like that. If you get the gradient magnitude is maybe 60, so it is lower than 100 preset value, so it is not an edge, something like that. And this one is to trace the angle of the edge. Okay, so that's all for today. We will continue question 7 next time. Okay, I think I will tutorial 5. Tutorial 5, I think only very last question. Okay, maybe later I will upload tutorial 6 . Okay, any questions? Don't return to math teacher, Yao Ting Long. That is very important. Many things is maybe you won't find that this is very important now, but later on, I really feel so is when I study, when I first year of my PhD, it been struggling, I would say, because I skipped my master and joined PhD. So of course, I saved some time because master take around 2 years, but I skip master and go to PhD. But first year of PhD is quite struggle because I not really that I don't know, but many things I already forget. So I have to restudy basic mathematics, this and that. Eventually, because my supervisor is graduate from UK, reputed university, so her English is very good. Even eventually, she asked me to study back the grammar. the 14th chapter of drama. So I studied each and every, I just go popular to buy the grammar and study each chapter just to write the thesis. Yeah, but that is a bit painful lah. But anyhow, it is a very very good experience as well lah. Something that I want. Okay, that's all for today. Thank you.